right, we are now recording. Let me get a couple of announcements. You've heard them all before. I've asked before if any of you are graduating this term. I didn't remember that anyone was. Any term after this term, remember, start your application for graduation process the term before you graduate. So this is the perfect time to start the process if you're graduating in the spring. And always remember the term before is the term to start it. Now, you can't finish the application, you could, but I wouldn't suggest it until after the spring schedule comes out, and then you register for spring so you'll know exactly what to put down on that application. But start with your degree audit, get with your advisor, and then apply online. As far as I know, they're still looking for note takers from the Student Services Office. So if you are able to take notes, please get in touch with Dr. Renee Herndon on this campus, Mrs. Janine Jones on the other campus. And the Space Center was still looking for peer tutors as far as I know, specifically math, which all would be good in, English, biology, computer science, and Spanish. On the Birmingham campus, they have the Space Center. On this campus, we have Space Center and Student Support Services. So if you would be able to do either one of those, they pay you to do that. Okay, so please take advantage of that. Now, any questions on anything we've covered so far? I do have an announcement for next week, but rather than start messing with that now, I'll wait till next week to announce it. It's something I do know is coming up for next week. All right, this is where we left off before. We're in Module 12, Section 12.1, Objective 12.1A, okay? And this is the focus on simplifying rational expressions by factoring at the bottom of page 3 of Module 12. So, if you're where you need to be, how would you approach a problem like that? It says simplify. What would you suggest doing? Any ideas, hints, suggestions? What would be your approach to simplify that? Any? Please have something to have in mind. Give it a shot. Second? What's the F word? Factor. Factor everything in sight. Now, which looks easier to factor, the numerator or the denominator? Numerator. So let's try factoring it. Is that factorable? Oh, let me get my pen set up. Okay. And what did you say it was? I'm sorry, I can't hear. How does the numerator factor? Okay, 3 times 3, got it. Little guy. Okay, plus x, minus x. Is that what you're saying? Perfect. Go on and FOIL it, and you'll see that's exactly what you get. I see's here. Anyone else come in since I called roll? No, I wasn't looking. Okay, so there we got the numerator factored. Okay. Now, to factor the denominator, don't think anything, you remember my little trick from last time, not really going to help you much this time, because either a plus 3 or minus 3 will work for that minus 12. So, you're just going to have to do brute force. So how would you start that? X times x. That's a good way to start. Where do we look next? Second? Negative at the sign of the last term. What does that tell you about these two signs? Opposite. So one's going to be plus, one's going to be minus. Okay? Now we want two numbers, and because they're different signs, we want two numbers that multiply to be 12, but whose difference is 1. 3 and 4. Okay? Which one is going to need to be the positive? The 4, because you got the positive wins in the middle. So we'll do the plus 4 here and the minus 3 there. Now, can you think of anything we might be able to do? Say again? Factor? I think we factored about as far as we can. Huh? Cancel. Uh-oh. Cancel word. What do you want to cancel? The 3 minus x. With what? Oh, those are the same, huh? No. Okay, I didn't know if he was giving me an army no negative or if he was saying make a negative. Okay, go ahead. Okay, if you factor out, and the factor was right here, factor out a negative sign here, that becomes plus, this becomes minus. Then you can write it as x minus 3. But you have to factor out that minus 1. Is that what you were saying? Okay, so up here, factor out the minus 1 from this one. I'm going to write it in that order then. X minus 3. And just to check to make sure you did it right, if you multiply through, that would be minus x plus 3. That's exactly what you got there. I just rearranged the order. Times x. I'm going to go and write that one as x plus 3. Why can't I do that? I didn't have to factor anything out there. They're both positive, but addition is commutative. Subtraction is not commutative. So you can't cancel out. Okay, so you have to factor out the minus 1 there, but with 2 positive numbers adding, you can change the order anytime you want to without penalty. The what?
And that root 3 minus x, when you factor out a negative 1, that negative still stays the same?
Yeah, when you factor out a negative 1, you could put a 1 there or just factor out the minus sign. But the x minus 3, that you've switched the signs here by factoring out the minus sign, right? Or factoring out a minus 1. Does that answer what you were asking? Okay. And in the denominator, you have x plus 4 times x minus 3. Now we can divide out common factors. Bing, bing. Okay? And what answer do we get? Minus x plus 3 over x plus 4. Okay? Is there anything else we can do to simplify? No. Don't even try it. Okay? You can only divide out things that are multiplied. The x minus 3s were multiplied up there, so we can divide them out. Okay? As far as you can go. There's our answer. There's our simplification. And truly, that's simplified. All right? Want to see how they did it? Are there any questions? Was there a question? Okay. All right. How did they do it? Well, they did the same way y'all did. They factored the 9 minus x squared is 3 minus x times 3 plus x. Perfect. Way to go. They factored this one as x minus 3 times x plus 4. They just got everything backwards, but that's okay. Multiplication is also commutative. Okay? Factor the numerator and the denominator. In other words, everything in sight. And then, what you have to do is divide out the common factors. Now, here's how they did the division. They said, this one will go into that minus 1 times. I'm not sure I think that way, or would even see it that way. I think I see it a lot better if I factor out the minus 1, make these look the same, divide those out, but then the minus sign stays outside. To me, that's a lot clearer. But this is correct, but it's sort of like magic. And I don't believe in magic as well. Okay. And then they leave that as, but then they went around and changed that order, which is fine, but minus x plus 3 over x plus 4, just like we got. Make sense? Any questions about it? Now here's one thing, a little bit on the downside here. And just about everything we've done up to now, you can always go back and check your answers. These, because you've eliminated things, there's not much way of checking, okay? So be careful, make sure every step is legit. You know that you can do it. All right, any questions on that? All right, that was the focus on simplifying a rational expression. Bottom of page 3, they show you their solution just like they did here, and they got the same one in the book. Good for them. Then there's a check your understanding 2, and please, as soon as you can after class, get that done. And then you have 4 practice problems. Objective 2.1A practice problems. Please do those 4 as homework. Okay? As soon as you can, later, whenever, but do that. Check your understanding as soon as possible. And that, I think, is the last slide in this set. I am so glad they have me changing this so frequently. It's just such a tremendous use of time. It seemed like they could string all these together and have a much better presentation. So I have to sit and wait for it to do this. All right. Notice, big 6 slides here. Wow. I feel impressed. They have really... What's that? Yeah. And I bet you at least 1 or 2 of these are almost identical. So from current slide, here we go. Yeah, it says from Module 12, Rational Expressions. We had that before. And Section 12.1, Multiplication and Division of Rational Expressions. We had that before. Now, Objective 12.1B. So 2 of the 4 we already had. 2 of the 6. So we only have 4 new ones. Here's one of them. Multiply rational expressions. Now, before I do that, what does rational expressions mean? What is a rational expression? And gender has nothing to do with it, okay? What do we mean by this? Rational expressions? Ratios to fractional forms that you're trying to multiply. So let's think back. How do you multiply fractions? Why in the world are they starting with multiplying when addition and subtraction easier than multiplication and division? Not for fractions. If you remember in fractions, what's so easy about multiplying fractions? You just multiply numerators and multiply denominators. Adding and subtracting fractional forms, you got to get a least common denominator first before you can add then just numerators or numerators, add or subtract numerators. Okay, so these are easier to multiply fractional forms of rational expressions. So that's what we're going to go to. The product of 2 fractions is a fraction whose numerator is the product of the 2 numerators of the 2 fractions and whose denominator is the product of the denominators of the 2 fractions. Boy, how can you say a simple concept any more complicated than that? But there it is, okay? So to multiply 2 fractions, to multiply the numerators, multiply the denominators. Done. You're done. Well, with one sort of exception. If there's common factors in here, far easier to get rid of them at this stage than wait until you multiply them together, then you got to go back and refactor again. So get rid of common factors early as you can, okay? Be smart about it. Now this one, no common factors between numerator and denominator, so you just multiply the numerator, 8, denominator, 15. I shouldn't have done that. Should let you do it. What would that be? 6x over yz. No common factors, perfect. How about that one? Y'all see? Yeah, it's just 3 times x plus 2 over x times x minus 2. That's it. Is there any reason to multiply to distribute those? None that I can think of. Okay, you can do it. Certainly is a correct answer, but it's not going to simplify anything. In fact, most of the time it's better to leave it in factored form just so you can see, are there any common factors? No, they're not. But leave it that way. No reason to make it more difficult just because you can do it. I mean, you can. You perfectly can. Perfectly all right to do so. Now, if you're doing WebAssign and did it, then they tell you it was a wrong answer. It wouldn't be a wrong answer. It would be perfectly correct. However, they're looking for only one answer. And there's several ways to express answers. Okay? So, any questions on that? All right, let's do one. All right. All right. Here we have 2 rational expressions being multiplied. What would you suggest I do with that first one? Should I just go on and and brute force multiply? You could, but what's a far better way? What's the F word? Factor everything in sight. In that first numerator, what do you look for? First thing you look for. Common factors, are there any? What? 5x, perfect. What's left? X minus, what'd you say? 3? Oh, yeah, you're right. 2x minus 3, right. Okay, I don't hear well. 2x minus 3. Everybody see that? Okay, how about that denominator of the first rational expression? Anything? 4. What you got left? A little louder. 3x minus 2. Okay. And let's do the numerator of the next one. Anything we can factor there? No, so just write it down. 3x minus 2 over anything we can factor into the denominator? What? 5. And what do you have left? 4x minus 5. Okay? Now that we factored, now look for common factors between numerator and denominator. See if we can simplify this any before we start multiplying all that mess together. Anything you see? Oh, 3x minus 2 can divide out. Okay, anything else? Five. Oh, clever of you to guess that. Okay, there's a 5 and there's a 5. Okay, so what do we have? Anything else? I think not. So what do we have left in the numerator? An x times 2x minus 3. And in the denominator, a 4 times 4x minus 5. Now, is there any real rational, logical reason to multiply those together? Not that I can think of. Leave them as simplified as you can. Okay? Who knows? Maybe they'll want you to take this answer and do something else with it later, and then you have to factor it again. So leave them like that, I think, is a good idea. So y'all jot down that that is the answer. We're going to go on and do the B part next. Okay? Then we'll come back and check our answers. All right, on the B part. Wow. Let me just cheat a little bit. Is that okay? In that first numerator, I hope it's going to factor. Okay? That's all I'm doing right now is hoping. And while I'm at it, let's hope the denominator will factor. Okay? It's pretty easy to hope, isn't it? In the second numerator, I'm going to hope it's going to factor. Okay? Boy, this is not bad. That denominator, I think I can factor it right off the top. That looks like the easiest thing to do, and I'm lazy enough that I'm going to go for the easiest first. It's not that funny. Okay. So, how does that denominator factor? Second denominator. 2. A little louder. Plus and minus. Okay, 2 plus and minus x and x. Got it. Okay. Now, just for funsies, since everything but that one is written in decreasing order of the powers, let's go and get this in decreasing order of the powers too. And what will that be? This is easy to do. X plus 2. You can exchange the addition anytime you want to. This one, factor out of minus 1. Okay? So what I'm going to do, if it's okay, is just mark through this and say x plus 2, and mark through this and say x minus 2, but I'm going to put the minus sign way out in front. Doesn't matter where you put it, right? So I'm going to put it way out in front. Just don't forget about it. It's there. Okay. Now, here's where the cheating part, the lazy part comes in. Not much help here, is there? Now, x plus 2 would go into that, or that. Oh, no, it's already in that. X minus 2 would go into that. Yeah, not going to help us any. So pick another one of those you think is fairly easy to factor, and let's go for that. Numerator on the first factor looks like a wiener to me. Okay? So how would that factor? X times x, perfect. Plus and minus, way to watch. And 3 and 2, that looks like it will work. Okay, let's check it and see. These you can always check. Remember, x times x is x squared. Good. Minus 2x plus 3x is plus x. Yes. Minus 6. Yes. Okay. Good deal. Now, if you wanted to right now, you can go on and wipe out the x minus 2's. No reason to wait. They're going to divide out. Now we need something with an x plus 3 in the denominator if possible. This is where laziness comes in. That will work here, won't it? So let's guess and hope, beyond all hope, that x plus 3 might be a factor there. If it is, what would be the other factor? X plus 4. Check it and see. Does it work? X times x is x squared. X times 4 is 4x plus 3x is 7x plus 12. Yes, it works. Okay? So now we can go on and get rid of our x plus 3's. Divide them out. Okay? Now, how about that last numerator? Frankly, either one of those denominators will work. X plus 4 will go into that, and x plus 2 will go into that. Which one you want to just factor? Not even mess with those? Or you want to make a guess? Either way will be fine. If you guess wrong, just try something else. Say again? Just factor it. How will it factor? X times x, perfect. Then you look where? Yeah, the sign, and what does that tell you? Okay, so one's going to be plus and the other minus, perfect. Now, we want two numbers to multiply to be 4, and because there are different signs, their difference is 3. 4 and 1 looks like that's going to do it for us. So which one's going to win? The sign. The 4 is going to go with the plus, and the 1's going to go with the minus. Okay? Check it and see. X squared minus x plus 4x, that'll be plus 3x minus 4. Yes, that works. Now your x plus 4's can go, and what do you have left? Oh, wait. Look at what I forgot to mark that out. Okay. What do you have? A negative x minus 1 over x plus 2. Okay? Now that's a perfectly correct answer. In fact, I'm guessing that's the one they give. But let me show you a little bit simpler answer. You can take that minus sign, multiply through there, and that will give you a 1 minus x. Just the same thing we did before, only we're multiplying through, and you lose the minus sign out front over x plus 2. Or you could put the denominator over 2 plus x. It doesn't matter, okay? All those are correct answers. Let me do the other one too. 1 minus x over 2 plus x. That works too. All three of those are perfectly legitimate, correct answers. Okay? I would accept any one of them with impunity, or with anyone else you should choose. Okay? So, any questions on that? Okay. Remember that answer, because I've got to erase all this stuff, and then we'll see what we got. On the first one, they factored everything just like we did. In fact, they did it the same way. 5x times 2x minus 3. Got it? This one was 4 times 3x minus 2. Well, let's divide out. They have the same numbers in them. Yeah, because the 2's and the 3's are in different order. They got to be identical before you can divide out. Don't even try it. I shouldn't have even asked. Okay, 3x minus 2 is perfectly fine there. You can go and get rid of them now. Okay, and when you do get rid of common factors, the 5's go out and the 3x minus 2 go out. They've been dating, okay? And that gives you 2x minus 3 over 4 times, x times 2x minus 3 over 4. Oh, I'm so glad they factored the 4 as 2 times 2. That was helpful, okay? Over 4 times 2x minus 5. That was totally unnecessary, but it works. So that's, they say write the answer in simplest form. So I guess that is simplest form, okay? Everything's factored. Okay, that's the same thing we got, right? Yes, okay. And the second one, factor everything in sight, and they just did it brute force, factored everything at once. And we kind of did too. We just were a little more selective what we did. And there they noticed that, and here they do the same thing they did before. They divided out the x plus 3s, that was fine. And they did the x minus 2 and the 2 minus x, and did that as a minus 1. Now if you see that and understand that, and that makes you warm and fuzzy inside, then go for it. But if it's more helpful to you to factor out the minus 1 and leave this x minus 2 and then divide those out, just don't forget about the minus up front. Okay? And I think we covered, oh, and the x plus 4. So that left us, now putting the minus 1 down there is so easy to mess up and forget there's a minus 1 in front of everything because it's down there. But they had to pull this from here to here. So that's the other reason I like doing it the other way. X minus 1 over x plus 2. And that's the only answer they would accept, but I would accept any of those 3 others, 2 others. Any questions? And that's what we got to, right? Yes. All right, good deal. So that's focus on, I wasn't even paying attention. I hope that was the first focus. No, it wasn't. There, you let me do it again, okay? Now, what I got to do is go back and do the first example. Sorry about that. Before we had a focus there, I should have done that. But you see, they do the same thing, get the same answers for the focus. Let me go back, okay, and do their 2 examples before they got to the focus. I wasn't paying attention. Here's the first one. 5xy to the 5th over 8a squared b to the 6th times 4a cubed b over 15xy to the 4th. Okay. How would you proceed on a problem like that? Now, there's several ways you can choose, and as long as you do everything right, they're all good ways. You tell me how you want to proceed. Say again? Someone have an idea? Where would you start? Say again? Simplify. How would you do that? Okay. All right. If this is what I'm hearing, I may be wrong, here's one way you can simplify that one. Do a prime factorization. 5 times x times y times y times y times y times y. That may not be what you had in mind, but that's one way you could go. Huh? Jackson? Johnson. Got it. I can't hear well, sorry. Okay, I know you're in here. Okay, there you are, right there, Kylie. All right, good deal. Oh, and I meant to tell you this too. I should have said this at the very beginning. I had one of the busiest weekends I can recall. Whine, whine. Okay, that's my sad song. And I didn't quite get to finish doing your grading your test. I'll give you a couple of the reasons for this. We are in the middle of trying to get spring and summer schedules put together, and they are a mess right now. I was told by someone that she was going to take care of part of them. and what little she took care of, some of it was wrong, so I've had to be correcting that and then adding more stuff. So that was my all-day Friday when I wasn't busy doing something else. I didn't get to grade anything to speak of on Friday. Then, over the weekend, like I said, a really busy weekend. And every little chance I had, I'd sit down and try to grade some when I didn't fall asleep in my chair. But anyway, it was exciting papers, by the way. But, so I didn't get them all graded. So that, and if I don't have them all graded, there's sure none of them out there on Blackboard yet. So if you want to check and see how you scored, the first part of the alphabet is graded down through, I'm really close to finishing the grading, but down through, I guess, Kylie. Kylie. I think I've got yours graded, but then the others I don't quite have graded yet. Okay? And I can't read something I just wrote there. But anyway, so if you want to see your scores, you can. Now, some people weren't here for taking the test, so anytime you want to make that up, great. Few people still haven't turned in quiz 2, so please get that done. Got to do that before you can do your test. All right, commercial break. Let's get back to this. Okay, there's that numerator written in fully factored form. That denominator, oh boy, what a mess here too. That would be, what's the smallest prime factor that will go into 8? 2 times what? Times what? Okay, does that give you 8? Yes. Times, how about a squared? A times a. How about b6? B times b times b times b times b times b. 6 of them there. Am I even going to have room to write them all? Let's try. How about 4? 4? 2 times 2. Got good. Okay. A cubed. A times A times A. And B is that cubed? I think it is. Yeah. Okay. And B is just B. Okay. And then that denominator, oh my word, that's smaller prime number going to 15. 3 times 5, got it. Then X, got that. And then 4 Y's. Y times Y times Y times Y. Okay, now we divide out common factors. What ones do you see? Say again? 2s, did I hear that? Okay, there's a 2 down there and a 2 up there, another 2 down there and a 2 up there. That gets all my 2s out of the ways that I can. Next. Second, A's. I see 2 A's down here. I'll wipe out 2 A's up there. Got it? Next. B's, how many? 1 B from each. Got it? Next. Y's, how many? 1, 2, 3, 4, and 1, 2, 3, 4. Got it? Next. X, just 1 here and 1 there. That's easy. And 5 here and 5 there. What are we left with in our numerator? Okay, say that one more time. Okay, let's do all the numerators. Yeah, an A times a Y. Okay, and then the denominator, a 2 times 3, which is 6. B to the, how many? B to the 5th. Got it. There, I think, is the answer. Okay? Let's see what they got. A times Y, good for them, over 6B to the 5th. Got it. Now, did you have to do all that prime factorization? No, but if that helps you, do it. There's nothing wrong with it. How I probably would have done it, but it may be because I'm used to doing this, I would have looked here and saw 5 will go into 15. How many times? 3 times. X will go into X 1 time. Okay. Down here, a Y to the 4th will go into Y to the 5th. How many times? Y times. So just wipe out the 5. Okay, here's a 4 up here and 8 down there. What would that be? 4 and the 4 once, 4 and the 8 twice. And here we have an A squared. Up there, A cubed. A squared will go into A cubed. How many times? A times. So leave the A there. And then a b up here will go into b to the 6th. How many times? B to the 5th times. Subtracting. Remember, when you're simplifying exponential forms, you subtract. If it's a division sense, you subtract the exponents. So that's what happened there. So at this point, then I can see up here we've got left a y times a times y. That's all that's left there. That one and that one. And down here we got a 6 times a b to the 5th. So you get the same answer. Now, what's the hazard of doing this? Missing seeing my a here, or the y there, or the 5th up here, or forget, There are problems with doing this, whereas that way, pretty much all strung out for you, and it's easy to see. But, especially that b and the b to the 6th, make sure you understand that right. You do them out that way, it's pretty obvious only one b goes out, okay? So, whichever way floats your boat, okay? So go with what you understand. All right, there was the A one up there. Let's do the B one up there. Gonna erase all this, draw my line back in, and let's do the B. Here's a x squared plus 3x. See, I should have done this one first. Over x squared minus 3x. Move, that's the minus 4. Please be careful copying. I usually see, I can't remember if in this class I saw any of these this time, but I've seen them before. Some error on the test will be because when they went from the front page to the scratch work, they copied the problem wrong, and then they worked a problem, may have done it correctly, but it wasn't the one that was given. So always check that, which I'm trying to do here. X squared. Okay, he's making fun of my writing. I understand it doesn't hurt that badly, but yeah, okay. All right, any excuse will do. Okay. All right. X squared minus 5x. Is that a plus 4? I believe so. Over x squared plus 2x minus 3. Okay. Good deal. This one we should have done before we did the other one. That one was a little more complicated. This one maybe a little easier. What's the first thing you want to do? Let's multiply those numerators together and multiply the denominators together. Does that sound like a great thing to do? Please don't. Okay, please get them as simple as possible before you multiply. So what could you do? Factor sounds like a wiener. What do we factor? First numerator. X, and what's left? X plus 3. Started with that one because that was the easiest one. Okay, now I'm going to be hopeful. Let's do a factor there times a factor here divided by a factored here. Now the reason I did this is I see I have an x plus 3 factor here. I know that won't go into this. That won't work. But it might go into that. So let's hope that x plus 3, we're just hoping now, there's no guarantee this is going to work. Let's hope one of those factors is going to be an x plus 3. Okay? What would be the other factor if that one was an x plus 3? X minus 1. Let's see if that works. Okay? X times x is x squared. X times minus 1 is minus x. Plus 3x would be plus 2x. Yes, and minus 3. Yes, that works. So we're happy campers. Okay. So there, the x plus 3 will go out with that x plus 3. Okay? Now we have x minus 1 in the denominator. Let's hope that's going to be a factor up here. So let's put x minus 1. That will work. What would be left? If that was a factor for the numerator, what would be the other factor? X minus 4. Let's see if that works. X times x is x squared minus 4x minus x would be minus 5x, yes, and plus 4. Yes, it does work. All right, so we lucked out there. The x minus 1s can go out. Now, could x minus 4 possibly be a factor down here? Let's hope it is. X minus 4. What would be left? X plus 1. Let's see if that works. It doesn't have to, but it might. X plus times x is x squared plus x minus 4x would be a minus 3x and minus 4. Yes, that worked perfectly. And we were really lazy about that one. Wow. Okay. And then the x minus 4s go out. And what's our answer? X over x plus 1. Now, is there any way we can simplify that? How? What's wrong with that? You aren't canceling, you're dividing out. Can you divide things that are added? No. It's only things that are multiplied. So no, resist temptation. You don't do it. Okay. Huh? Yeah, that's done. Okay. All right. Let's see if that's what they got. Oh, look at that. They got the same thing. X over x plus 1. All right. And we've already done our focus, or foci. There were 2 of them. There's a check your understanding 3. Please do that. There's 2 parts to it. As soon as you can after class. Okay. Get that down. Then anytime after that, do your 4 practice problems. Okay, do them all. All the answers are at the back of the section. Or back of the module, I guess it is. All right, so I think we've done all that we can here. These are things we had already done. And there's the end of the section. Or objective, I guess it is. All right, so we'll discard that, change this, and go to 12.1C. That's what's coming up next. All right, and now we get set up for the current slide. And again, we're doing Module 12, Rational Expressions. I'm glad they keep reminding us of that. And we're in 12.1, which is Multiplication and Division of Rational Expressions. Now let's see. We've done multiplication. What would be left? Division of rational expressions. So that's what we're going to do next. Divide rational expressions. Wait a minute. Remind me, what's a rational expression? Ratio, which is like fractions. How do you divide fractions? Say again? Really? I didn't think so. How do you divide fractions? Second? Okay, you flip over, you do a somersault. No, it is called invert and multiply. Or multiply by the reciprocal. Remember those words? All right, that's it. Okay? Don't go dividing. Okay. All right. So, we will keep that in mind. So, here we have a choice, folks. We can either, in the rational expressions you have, if it's a division in between, keep the first one the way it is and invert the second one, and then do our factorization. Or you can factor first and then divide. I think it's most of the time better to invert first and then do your factorization. Otherwise, you might forget to go back and invert. So, not that you would forget to go, never mind. Or divide something that you shouldn't. Okay. So, here is what we're talking about. They're giving us a little bit of review here. The reciprocal of a fraction is what? When you flip it. Exactly. Okay? When you flip numerator and denominator. So A over B, its reciprocal would be B over A. X squared would be, again, 1 over X squared. Perfect. X plus 2 over X would be its reciprocal. X over X plus 2. Perfect. Okay? That's just a little reminder of what we mean by a reciprocal. Or an inversion, when you invert and multiply. Okay? So to divide rational expressions, divide 2 fractions, multiply the first fraction that you never change, leave that alone, by the reciprocal of the second, the divisor. They call this the dividend and the divisor. Multiply, multiply the first, excuse that, I gotta see. Now, wake up. Now you should be. Okay. Now, write down the first fraction form just like it was, and then multiply, rather than dividing, multiply the reciprocal of the second, the divisor. And then you do your multiplication. But in reality, we always factor out common factors after we do this. Don't do it here. After you invert and multiply, or multiply by the reciprocal, that's when you factor and start dividing out common factors. Okay? So, here's an example. 4 over x divided by x plus y over 5. I can't read. What would you do? First step. 4 over x times 5 over y, and that would be 20 over xy. You got it. This one. Oh, wait. You can't see it. Okay. All right. Okay. X plus 4 over x divided by x minus 2 over 4.
X plus 4 over x.
Got it. Times 4 over x minus 2. And then what could you do? Not much. Just multiply. 4 times x plus 4 over x times x minus 2. Perfect. Nothing you can do to simplify that, so just go on and multiply. All right. Everybody got it? All right, let's do something. Oh, wait. Let me check and make sure they're not skipping around here. Oh, they give you the basis for the division rule, which is perfectly okay. It doesn't make it any clearer to me, but it's okay. All right, I don't know why they went through all that mess. Okay? Yes, the next is this focus, and this is the one. So this time when I look, it is exactly what they do next. So what do we do to that first one? Let me get my pen set up. What should we do first? Write the first one, xy squared minus 3x squared y over z squared. Now, in reality, folks, when I'm doing this, I'm factoring that the first time. And after a while, if you get confident enough to do it, you can do that too. I see no reason, if I can see how to factor that first one, not to go on and factor it while I'm doing it. Or at least the first step in factoring. But we're doing it the way they say first. So, and then what do we do? What do we do? Multiply by reciprocal, which is z to the third over 6x squared minus 2xy. And frankly, I'd already be factoring that one. But you don't have to. Take it a step at a time. How do you eat your 5,000-pound elephant? One bite at a time. Okay, so take it easy. You don't have to rush things. Now what do you do? Factor. Excellent. And what do you factor in the first numerator? An x and a y. And what do you have left? Y minus 3x. Perfect. And the denominator, nothing much you can factor unless you want to string it out, but I'm okay with z squared if you are. Next. Z cubed. Okay, I'm okay with that. You could write z times 3, z if you wanted to, but what is next? A 2x, and what does that leave you with? 3x minus y. Now what do we do? All right, he says let's take out a minus 1 here and make this a 3x minus y. Is that what you meant? That is absolutely correct. Okay, now what? Now we can divide out the 3x minus y, don't we? Yes, okay. Anything else? So an x, we can wipe out an x here and there. We're dividing it out, not wiping it out, but whatever. Next. Okay. The z squared will go into z cubed how many times? Z times, okay? Z plane. Never mind. What would this give us? Okay, minus, don't forget your minus sign. And then a yz, is that what you said? Over 2. That's it, folks. There you have it. You ever think that thing was just going to wind up being that simple? Sometimes life is nice, okay? Now, always is nice, okay? Now, guess what? You can write this some other way. You could have written this as minus yz over 2. That's the same as this. Or yz over minus 2. That's the same. This is just, to me, an easier, simpler, more direct form. But any of those answers are correct. Okay. We'll see what they do in a minute. Let's go on and do the B one first. What do you do first? Help me. Okay. If you factor, be careful. Are y'all okay factoring? Okay. We don't have to. We can do it the other way. You okay? Okay. Let's see what we get if we factor. All right. I'm going to be hopeful here. Okay. All these look, in a sense, fairly complicated. So it doesn't matter where we begin. Where do you want to begin? Numerator, denominator? Numerator, okay. What's the only possible factorization? 2x squared. 2x times x. Perfect. Next. Where do we look? Okay, sign of the last term, and what does that give you? They have to be the same, and since you look at the middle, what are they? Both pluses, okay? Now, here's either trial or error, or you have to go back and do the AC method. Which you want to do? Okay, did you say a plus 4? You're looking over here. You're looking right here. There can't be a 4 in that. It's going to be a 2 and a 1 or a 1 and a 2, right? Only possible factorization for 2 is 1 times 2 or 2 times 1. And let me give you a hint. It can't be a 2 here. Why not? If there were 2 here, there would have been a common factor of 2. Did you see a common factor of 2? No. So that means this has to be the 1, that has to be the 2. So use all your investigative tools to your advantage here. That has to be a 1, that has to be a 2. Let's check it and see. I always like to check and see. I don't like making wrong answers, okay, even though I make too many. 2x times x is 2x squared. That's all right. Plus 4x, plus x, plus 5x, plus 2. Yes, that works. All right. Now that that's done, you could use either the 2x plus 1 or the x plus 2 in the denominator. They both would work. So rather than try around that way, let's go on and factor that denominator. What's the only possible factorization? 2x squared? 2x times x. Then you look where? Sign of the last term, and that's negative. That means these two are opposite. Which way you want to try first? Positive and then negative? We'll try it. And what's the only possible factorization of 2? 1 and 2, and we'll have to do it that way because it couldn't be a 2 with the first one. That meant there's a common factor of 2. There's not a common factor of 2. So let's try it and see if this works. Okay. 2x times x, sure enough, is 2x squared. 2x times minus 2 is negative 4x. Plus x would be negative 3x. But what's wrong with it? The sign, not the number. The number's fine, the sign's wrong. So what we do down here, change signs. Change signs. This is an easy way to do it, okay? First, we'll make that the minus and make the other the plus. Now let's try it again just to make sure that's going to do it for us. 2x times x is 2x squared. 2x times 2 is plus 4x minus x's plus 3x minus 2. Yes, that works. Okay? And now we see before we do anything else, we can wipe out those two. Okay? Now what you want to do next. And this is where it's easy to sort of get lost when you're doing this. So what do you do next? Yeah, you multiply by the reciprocal. Now, you want to go and factor there too, or is it easier to write them down? Okay, yeah, I see some lazy people in here. Okay. All right. But you got to remember what you're factoring because you're flipping them. So we're going to do the denominator on top. What's the only possible factorization for 2x squared? 2x times x. And then you look where? Sign of the last term, that's a negative, which tells you these two have to be, say again? The opposite. And which way you want to write them? Say again? Minus and plus. He thought the other way worked better. Okay, never mind. Now, only possible factorization for 4. There are 2. 1 and 4 and 2 and 2. You think 2 and 2 will work? No, because then you have a common factor of 2. You do not have a common factor of 2. So it's got to be 1 and 4, 4 and 1. Which way you want to do it? -1 and +4? Let's try it. Okay, let's try it. -1, +4. You've been looking ahead, haven't you? Okay, woo. Oh, I'm looking at the numerator, not the number. Let's see what we got. 2x times x is 2x squared, that's fine. Plus 8x minus x plus 7x minus 4. Yeah, y'all looking ahead. Okay, good deal. Okay. And then we can go on and wipe out our 2x minus 1 if we want to. Okay, this is going well. All right, now we got that numerator left to do, right? That's going to be down here. Going to have to factor that. And let's just start the factorization process. What's the only possible factorization? 3x squared. 3x times x. Okay, now look back up what we got left above. 3x isn't anywhere. So I'm hoping that next one's going to be a what? X plus 4. Now it doesn't have to be, but it certainly would work. What would the first one have to be then? 3x plus 1, right? Because plus plus?
You gotta change the 1 to a 4.
Oh, 4, yeah. I thought you said 1. Okay, 4.
No,
Not that one. Oh, goodness gracious. What is wrong with y'all today? Y'all are, it must be a Monday. Y'all seem really weird today. Okay. How will this work? Let's see. Is that right? Yes, that should be right. Let's see if it works. No guarantee that things are going to work out the way you want. You've been alive long enough to know that's not true, right? So let's see. 3x times x is 3x squared. That works okay. Plus 12x plus x is 13x plus 4. Y'all must be living right. Okay, never mind. They just gave you easy examples, didn't they? Now what can we do here? Divide out the x plus 4s. And what do we have left? 2x plus 1 over 3x plus 1. Can we simplify that any? No! Okay, good deal. All right. Now, that was a fairly complicated example, especially to try a new technique. If you're not ready for that flipping and factoring all at the same time, don't do it. Take as many steps as you need to make sure you understand what's going on. No reason to rush things, folks. It's not a time trial, okay? Do it correctly. That's the first thing. If after a while you get tired of and you know how to do it, then go on and invert and factor at the same step. But be careful when you do it, okay? All right, any questions on that? And by the way, in the book, they got a 2x plus 1 over 3x plus 1. Good for them. In fact, they may even show us how to do it. So let's wipe out my scratch. How are we doing on time?
Running out pretty quick.
Oh, do I look like I can run? No, never mind. Okay. All right. Yeah, I am or not. Okay. So let's see what we can do. All right. In that first one, what they did was write it down again, which is an excellent move. I would do that anytime. Then they inverted first, multiplied and inverted, which is a good thing to do, and I think that's what we did. And then they went about factoring. Wow, did they ever skip steps here? Okay, so they did factor out an xy, left us a y minus 3x times z squared, and there have a z cubed, a z squared down here, and factor that to be a 2x times 3x minus y. Good deal, and that gives us. Now remember how they like to do it? They like to do this one and that will go -1. If you see that and understand it, fine. If not, factor out a -1 and then you see that those can divide out. Okay. And then you have an x going out here and here and a z squared going out there and there. And I guess they just skipped to one step, yeah, a minus xy, a yz over 2. Wow, they skipped some steps there. Some of those I think were unnecessary to skip, but it's fine. Any questions on that? Same thing we got. Okay, let's look at the B part. And the first thing they did, and this is perfectly fine. In fact, recommended often. Write down the numerator of the first rational expression just like it is, then multiply by the reciprocal of the second. That's not a bad way to do it. Just to make sure you got everything in place. Now factor everything inside. You can factor as you go, or like we did, or you can do it this way. Either ones are perfectly fine. And when you factor this, just like we got 2x plus 1 times x plus 2 over 2x minus 1 times x plus 2, those go out. This gave us a 2x minus 1 times x plus 4. 2x minus 1 went out. This gave us a 3x plus 1 times x plus 4. They went out, leaving us 2x plus 1 over 3x plus 1. Simplest form. Can't go any further. Don't even try. I mean, look, always. But you can only divide out things that are multiplied, not added or subtracted. Okay? Got it? Any questions? All right. Whoa! End of the section? Yeah, there is a check your understanding for. Please do that as soon as you can after class. And they have answers over in the supplementary part. And then do your 4 practice problems either later or homework or whenever you can get around to it. Okay, how are we doing on time? Oh, we got a little bit of time, don't we? Yeah, we do. What's that? No, look at this. 9:41. 4 minutes. 4 minutes. No. Oh my goodness. Here we're starting a new section and y'all wanting to leave with it, okay? Well, get it out, okay? That's easy. All right, we'll go from slide. It's just going to be a couple of familiar slides. Okay, sorry about that. Might as well get them done now rather than have to do them next time. Module 12 is still rational expressions, but we've gone to a new section now, 12.2, which is addition and subtraction of rational expressions. Now remind me, what do you have to do when you're adding or subtracting fractional forms? Common denominator. And boy, with rational expressions, that could be a little hairy. You have to be careful as you go. So that's what we're going to be doing. So objective 12.2A is express 2 factors in terms of a common denominator. Okay, a common denominator. Okay, we're going to start with easy things, fractions. Those are always easy, weren't they? Okay, the least common multiple, also sometimes called least common denominator, of 2 or more numbers is the smallest number that contains the prime factorization of each of those numbers. So what's the least common multiple of 12 and 18? What we're going to 12? 6 times 2, and 6 is actually 2 times 3, so it's 2 times 2 times 3. Now how about 18? Hey, you can use that 6 again, can't you? So who cares about that? 6 times what? 3. Okay? So you got to have a 6, got to have another 2 and another 3, and 6 times 2 times 3 is? 6 times 6 is 36. Sure enough, that's your least common multiple, which later we'll talk about least common denominator. Contains all the prime factorizations, both of 12 and of 18. Now, you have many that are greater. You can just multiply 12 times 18. Big old number, yeah, that's common too, but it's not the least common. The least common is one that has 2 times 2 times 3, 2 times 3 times 3. So it's got to have 2 2s and 2 3s, and sure enough, that's 36. Okay? Here's how they do it. 12 is 2 times 2 times 3, 18 is 2 times 3 times 3, and you have to have at least 2 2s and at least 2 3s, and that gives you 36. All right? That was reviewed. That wasn't that painful, was it? Don't answer that question. Okay. All right. I guess we'll start with this slide next time. All right. Since y'all are so eager to go and leave me in here all alone, okay, we'll live with that. All right. Good deal. Any questions? All right. And here I got people showing up here. I bet you someone wants to see test scores. Okay. Okay, I need them back. Oh wait, that's your quiz. You already seen that. All right. There's yours. I need them back. Don't let them get too far. Cameron's not here. Emmett's here. I need them back, so I don't go anywhere with them. Tasha's not here. Ariana. Oh, there you go. Okay. I need them back. Don't go anywhere with them. Ashley, not here. Good deal. Thank you. Messiah, not here. Kirsten's here. Kylie. Okay. Why have we got no? Oh, here we go. Far enough back. Drew, yeah, okay. Don't go anywhere. I need them back. And Bob, that's Ossie. Okay. Lexi, okay. Seth. Hey. Okay. Just kidding. Okay. Pablo, is Pablo here? Okay. Look at these eyes everywhere, okay? Everybody got to see it that needed to see it? Okay. Oh, no, I didn't get as far as yours, remember? I only got down to yeah.
Oh, okay.
Yeah, you're too late in the alphabet. I'll get to you hopefully today.
All right, thank you.
All right, sorry about that.
Do you see if I can schedule a time for the ticket?
Oh, yeah, when do you want to? Okay, you want to take it right now, or? You can't? Okay. I forgot them all back. Okay, we'll have to go to another room because another class coming in here. So let's see what we can find. I just saw those.
What was your MOS in the Navy,
Have you
sir?
turned in
The quiz, yes,
quick?
sir.
Okay, I thought so. What did you say? Sorry.
What was your MOS in the Navy, sir? What was your MOS in the Navy? I don't know
Oh.
what you guys call it.
Yeah. I was one of those rotten guys.
Which guys?
And O's.
Oh.
Yeah. So I was started off in communications. I was a communications officer, and I was in charge of radio and signal bridge. And then I moved to gunnery and 3rd Division officer next. And then on the next ship I went to, I was combat information center officer, so surface warfare. So I got around several areas. What was yours?
No, I'm still in, but
Huh?
I'm in the Army, so.
Yeah, I know, but what's your
I was infantry. Now I'm
infantry?
Yeah, now I'm support.
Support? Oh.
Yeah, because I went from active duty to the reserves.
Oh, I see. Okay.
And
So that's how you can do this. Oh.
And the reserves don't have
Yeah.
combat MOSs.
Oh, is that right?
Yeah.
I didn't know that.
The only combat unit in the reserves in Hawaii.
I see. Okay.
So,
Yeah.
the whole reserve is support. So
Right.
I had to change to
Yeah, support. Okay.
Yeah.
That's not too bad. Is it?
Nah,
Okay. Yeah. Good deal.
it's chill.
What's that?
It's a different scenario.
Yeah.
But I went to human resources.
Oh.
So
Okay.
now I just handle pay.
Yeah. Oh, pay. Okay.
I just handle finances.
Yeah. Well, good. Well, you need the math then, huh?
Yeah.
Yeah. Good deal. All right. Well, good deal.
I go from making battle movements to let me see why you ain't getting paid.
Yes, exactly. And sometimes they get madder at you for that, don't they?
Yeah, but most of the time I can fix it. Most of the time.
What's that?
Most of the time I can fix it.
Right. Exactly.
I just got to send a form out or
Right.
something.
Exactly. Yeah. I have a nephew who went in the Navy, and he went into supply, so he was a supply officer on the ship. I can't remember if he started off in payroll, or if he started off in ship services, or some of the other. There's several things under supply. Yeah.
Mm-hmm.
Yeah. So but he did all of his officer deck type stuff, and that kind of stuff too. So
I work in two offices. It was second office. I work in two offices. We called it two.
Uh-huh.
I don't know where
Yeah, well, good deal.
it's
And
chill.
your unit is around here?
Yeah, it's in, right now I'm in Fort Benning because
Because
of my knee.
Right.
So you heard of WTV?
No, what's that?
I was in Kuwait for a transition.
Uh-huh.
Like I was helping units transition and took like Afghanistan or Iraq,
Mhm.
whatever, and Syria. I tore a ligament in my knee.
Yeah.
And
And you can't do infantry with that.
no, and like since it happened on active duty order, like
Right.
Title 10,
Right.
they put me in WTV. So like right now I'm still Title 10.
Okay.
So right now I'm at home and I just go to physical therapy twice a week
Right.
until my next evaluation is November.
Uh-huh.
And he looks at my knee again. If he says I'm good, then I'll go back to my reserve status.
Okay.
But right now I'm just active duty.
You're getting active duty pay and not doing
BH.
very much. Yes.
I'm getting BH. I'm getting
Oh, wow.
everything.
Good deal. Are you married?
I am.
Yeah. Okay. So that's good to get.
Better.
Yeah.
Get a little couple hundred more.
Yeah. Back when I was in the Navy, if you were single, the ship was considered adequate lodging. So,
Yeah.
but if you're married, you got
Outpost.
outpost. Yeah.
Yeah, the Army's the same way.
Well, now in the Navy, if you're single, you get the others do.
It depends your rank.
Yeah.
Right? It goes by rank.
Yeah.
Because if you're like, I don't know, you guys have E4. Like you guys go by E's.
Yeah. Right.
Yeah, like in the Army, if you're like E4 and
Yeah.
below, you live in the barracks. If you're
Yeah.
single.
Right.
But you can be an E1 and married, and you can live outpost.
Yeah. Right. Yeah. Doesn't seem right, does it?
No.
Yeah, I was single the whole time I was in.
Yeah.
So therefore, when you first came back from port, you knew the single guys had
Like-
duties that first day.
When I was at Fort Hood, I was single.
Yeah.
So like, I lived in the barracks.
Right.
You don't live the Army life. You lived in the barracks.
Yeah.
So
Exactly.
you see the stuff in the barracks.
Right. All right. Well, good deal. Well, I hope your knee continues to go. You have to pull it out and wipe it. Yeah. It's high tech. Okay. It got a lot of abuse in its early life, and so
You in the next class?
Cal 2.
You don't teach that class, do you?
Huh?
You don't teach that class?
Yes, I do.
Oh, okay.
I haven't gone down to do that. I'll just sort these.
When did that class start? When did it start? No, when does it start?
Yeah.
What time?
10.
At 10?
Yeah.
So I don't have time to take the test then.
Yeah, but I said you'd have to go to another room.
Yeah.
I got the test for you. Okay, we've just been yakking. Okay. So,
All right.
let's see here. This room's taken here. I'll be back in a few minutes. close. I'll be a little bit longer. Okay. 2 people turned that in. So I need to have a key for it.
Do you think that we'd have time to answer a couple of questions about the test?
Sure. Let me check and see if everyone's turned them in. If they haven't, I can't record those. Okay. But if no one's here that hasn't turned it in, I can go over it. I'll have not to record it. And I didn't end my recording.